Okay, let's go back to the beginning of the chapter when we took a function. We'll take something simple like this and call it f of x. And we looked for the area under the curve using rectangles. We had 4 different types of rectangles. Inscribed, circumscribed, left hand, right hand. We also hinted at something called a midpoint, which we didn't really deal with. But when we did that, we noticed that we got all kinds of problems here because our answer wasn't very accurate. So let's say, for instance, get my melon out of the way. We do a left-hand rectangle for this. We would get here, 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 and there. And we have all this wasted space. So this is just a review of what we talked about. And we...
Right hand?
That's a right hand, yeah, thank you. Did I say left hand?
Yeah.
Sorry. I have trouble. I didn't do this to remember. We talked about how to decrease the amount of waste. And what was the answer to that question? How do we decrease the amount of waste?
Make smaller rectangles.
Smaller rectangles, or increase the number of rectangles. Today, obviously, we have another way to eliminate some of the waste, and that is to, instead of using rectangles, we're going to add trapezoids. So instead of doing this, we're just going to connect this to that. And you can see, depending on the graph, how much more accurate those trapezoids are. And you have to imagine those are trapezoids turned on their sides. Okay, so first things first, quick refresher. What's the area formula for a trapezoid? 1/2
Base 1 plus
Quantity.
base 2.
Base 1 is type 1.
base 1 plus base 2 times h. Good.
How do you know how to draw the diagonal from the trapezoid? How do you know
Oh, the slant, connect the points where it hits the graph. So notice when I drew these vertical points up, it hits here and here. You just connect those.
Is that kind of like a curve?
This is curved, yes. The trapezoid would be straight.
Looks like a triangle.
And again, remember, this is a trapezoid turned on its side. You're used to geometry, you're used to dealing with trapezoids like this.
Yeah, I understand that.
So I took that and stood it up on end. And in fact, I made that perpendicular, because that's the bottom.
There's still waste, but a lot less.
Correct. Okay. Just a quick review. How do we find delta x? Which in the picture would be here, delta x.
Number
B
4
minus A
divided by
Olivia?
B minus A over N.
Well done. Starting point minus, or sorry, ending point minus starting point divided by the number of rectangles. In this case, we have 4 rectangles. If we take the geometry and marriage it with the calculus, then h in this formula is the same thing as delta x, because again, we've tilted that triangle up on its end. So we're going to look at this triangle specifically. 1, 2, 3, 4, or that's not triangle, that's trapezoid. So the height of that trapezoid is actually delta x, so it becomes 1/2 delta x times, what's base 1? F of 3, good.
Yeah.
Plus, what's base 2? F of 4. So that'll find the area of that last trapezoid in the picture. Just for giggles, what's the area of the first trapezoid? What's base 1? F of 0. And what's base 2? F of 1. My recommendation would be to just find the area of each of those trapezoids and add them up. There is, however, a formula to find the area using trapezoids called the trapezoid rule. I don't find it very helpful. I'll write it down so you can say you saw it, but it's not the most practical thing in the world. It goes something like this. last thing was supposed to be a parentheses.
What is that for?
That's the trapezoid rule.
Why is it 10 to 2? Okay.
Great question. I was hoping somebody would ask that. Why are some of them multiplied by 2 and some of them not? The ones that aren't are the first and the last one. So if I calculate the area of this one, it would be 1/2 delta x f of 0 plus f of 1, which we have right here. If I calculate the area of the second trapezoid, I would have 1/2 delta x times f of 1 plus f of 2. So you notice that the first trapezoid uses f of 1, the second trapezoid uses f of 1. The second trapezoid uses f of 2, the third one uses f of 2. So every height, which is actually a base, is used twice except the first and the last. To me, remembering that and keeping everything straight was so confusing, so I never used that. I just attacked it from a geometric standpoint and said, okay, I've got 4 trapezoids that I need to find the area of. Find the area of each individual one, add it up, you're done.
Are we ever gonna have like a ridiculous amount of trapezoids for that stuff or not?
I will not give you a problem with a ridiculous number of trapezoids where you're forced to use this or do some crazy calculation. Every problem that I give you can be reduced to the geometry aspect. That's why I'm focusing on it that way. Okay? Easy? If you got the rectangle stuff under control, this should be fine if you can remember the formula of a trapezoid. Okay. We good?
This isn't what it was?
No.
No, it's 4 or 5.
Yeah, 4 or 5.
Just 4 or 5.
The quiz tomorrow?
Just.
No. Just covers 4 or 5.
Just.
Just 4 or 5.
Write
Yeah.
down the really?
Right. Eric? It's just 4 or 5 tomorrow.
Does this have any practical use, or, because if we know how to use
Just gives you a more accurate answer. I don't, to be honest, I don't really know why this, there's some mathematical reason why we wait until now to do the trapezoid rule. I don't know what it is.
Alright.
I could look into it, but it would seem logical to go rectangles, trapezoids,
Yeah.
fundamental theorem of calculus, but there's something that I'm missing that forces that to get pushed back.
Alright.
So tonight's homework is to review the quiz.
Tonight's homework is this,
It's on that?
4-6. Right. And also study for the quiz.
Which is on 4 or 5.
Yeah, the quiz is on 4 or 5 for tomorrow.
Yeah. For
It's just 4 5.
Just 4 or 5.
Really?
I hate this class.
it's fine.